So before we get into talking about these calculations with the colligative properties, we have to talk about the Van't Hoff factor. Okay, this is this lowercase I, which is the moles of ions in solution divided by the moles of solute dissolved. Now, we can very easily determine the expected Van't Hoff factor by the following. If I look at sodium chloride, okay, when I dissolve sodium chloride, it breaks up into two ions, Na plus and Cl minus. Because it's breaking up into two ions, now look at this formula, right? If I dissolve 1 mole of sodium chloride, it breaks up into two ions. So sodium chloride's Van't Hoff factor, the expected Van't Hoff factor, is 2. Okay? 2.0. Or let's just say 2. Okay? So what about sodium sulfate? Okay? Well, when sodium sulfate dissolves, it's going to become 2 Na pluses and 1 sulfate. So its expected Van't Hoff factor is 3. 2 sodium cations plus 1 sulfate anion. So what about calcium phosphate? Well, we recognize it's going to become 3 calcium 2 plus 2 PO4 3 minus. So that is 5 ions. So a Van't Hoff factor of 5. And this is really important to consider, this Van't Hoff factor and the calculation of the colligative properties, because again, the colligative properties depend upon how many things are in solution. Now, these are our expected values, okay? And so for the exam, that's only what I'll hold you to, is just being able to come up with the expected Van't Hoff factor, okay? Just by looking at how many ions are in the formula. So in reality, sodium chloride's Van't Hoff factor might be something like, 1.9, okay? Or 1.95 or something like that. Or maybe sodium sulfate's Van't Hoff factor in reality might be like 2.9 something, okay? And the only way we can know that is by measuring it, all right? So the only thing that I want you to have committed to memory is how to do the expected Van't Hoff factor. Getting the realistic Van't Hoff factor, you might be given the realistic Van't Hoff factor in a homework problem, but I don't expect you to just be able to come up with, oh, in reality, sodium chloride's Van't Hoff factor is observed to be 1.9. It's kind of impossible for us to know that. We would have to try to dissolve a mole of sodium chloride and then actually measure how many ions actually dissolved, okay? So moving on.